Consider the functions f and g given by f of x equals log base 10 of x minus 1 plus log base 10 of x plus 3, and g of x equals log base 10 of x plus 9. In the xy plane, what are all the x coordinates of the points of intersection of the graphs of f and g? So we need to find the x coordinate of the points where f and g intersect, meaning we need to find where x and f of x and g of x are all the same. So we can do that by setting f of x equal to g of x and solving for the value of x where this is true. So we can write that as log base 10 of x minus 1 plus log base 10 of x plus 3. This is f of x, and it's equal to g of x log base 10 of x plus 9. Now we see that we have this addition on the left-hand side here, and using log rules, we can just simplify this to multiplication. So log base 10 is actually equal to x minus 1 times x plus 3 is equal to log base 10 of x plus 9. This is just a log rule, where if you add two logs, it's the same thing as taking the same log of the multiplication of the two arguments. So now we see that we have log base 10 of something and the log base 10 of something. So we can just simplify this down to setting the arguments equal to each other. Because in the case where the arguments are equal, then the equation is equal, because all we're doing is just taking the same log of each. So what we really need to solve for is the value of x when x minus 1 times x plus 3 equals x plus 9. Because if we can find the value of x that makes this true, then this equation will automatically be true as well. And that will be for the same value of x. But this equation is much easier to solve for than this one. Okay, so let's simplify this down. So x times x is x squared, x times 3 is 3x, negative 1 times x is negative x, negative 1 times 3 is negative 3, and on the right we just have x plus 9. Let's move the x plus 9 to the other side. So we'll still have the x squared. 3x minus x is equal to 2x. Then if we subtract another x, that's just x. And then negative 3 minus 9, that's negative 12 equals 0. Okay, so now we can further simplify this. We can split the middle term into, so we'll have x squared plus 4x minus 3x minus 12 equals 0. So 4x minus 3x, that just gives us back to x. So this is equal to this equation. But to factor by grouping, we need to split the x term into two different coefficients that when multiplied equal a times c. A in this case is 1, c is negative 12. So 4 times negative 3 equals negative 12. And this will allow us to factor by grouping, as you'll see now. So let's factor out the x from the first two terms. So we'll take an x out of x squared, so we'll have an x left over, and an x from 4x, so we'll just be left with 4. Then we can factor out a negative 3 from the second two terms, so we'll have an x left over in the first term, and a positive 4 in the second term. So now this is identical, equivalent to this up here, but now we can see that x plus 4 is common to both. So let's factor that out. So we'll have an x plus 4 on the outside, and we'll multiply that with x minus 3. So this is the fully factored form. So now we can just solve for the values of x. We have x equals -4, and x equals +3. Because when x equals -4, this becomes 0. -4 plus 4 is 0, and anything multiplied with 0 is still 0, so this satisfies the equation. And the same with 3. When x is 3, 3 minus 3 is 0. So now we have these two values of x. But remember that we're dealing with log equations here. And we see that you can't take the log of a negative number. Negative values for x aren't in the domain for log functions. So we can rule out the negative answer. And only +3 is in the domain for x in log functions. Because if we plug in -4 for x here, we'll have the log of -5, which doesn't exist. So that means only 3 is the x-coordinate of the point of intersection of these graphs. So A is the correct answer.